The Iron Ore Company of Canada, or IOC, is Canada's largest iron ore producer and a leading global supplier of iron ore pellets and concentrates. This facility began operation in 1962 and has produced more than 1 billion tons of crude ore. The average blast moves over 750,000 tons of material. Haul trucks carry 170,000 tons per day, and a fully automatic train moves the material 13 kilometers to the crusher. After processing, the pellets and concentrate are transported south 418 kilometers to the company's shipping terminal and year-round deep-water port in Septiel. The mine is located in the northeastern corner of the North American mainland and borders the chilled waters of the North Atlantic, making the region susceptible to both maritime and continental air masses. Most areas around the mine have snow on the ground continuously for over half the year. IOC's wireless Rajant breadcrumb network enables IOC to reliably operate all data communications over a common wireless infrastructure. Mining applications such as dispatch and equipment condition monitoring seamlessly ride on the same network as digital video from remote cameras and process control information from remote sensors and switches. Work is now underway to move mine-wide voice communications to wireless phones running on the Rajant network. Like many surface mines, mine-wide line-of-sight wireless communication is nearly impossible at IOC due to obstructions. A multi-hop or repeater network might improve coverage in some areas, but experience has shown that the constantly changing topography in a mine usually results in the need for full-time monitoring and repositioning of mobile repeater trailers.
That's the repeater trailer over there, okay? That's FG09. That's our repeater point at that point to get right back to the MMF or back to the mine engineering building. We've got to get signals out of that hole over to there, out of that hole up to there or up to there, and out of this hole up to here or up to there. So we got, three different holes, and we don't have that many degrees of freedom, so we can't see all the different spots. So this is why there's quite a few different repeaters. You don't need this many repeaters for, if you had a flat surface, right? But we're proud of our trailers, that's for sure. We know we're not going to have too many problems with these guys, right? The boxes are fairly simplified. You have overrides for your wind turbine. So this is your solar panel controller, which you can see up there, solar panel. This controls the rate of charging so that you don't overcharge the batteries. Right now you've got ample solar power during the summertime. Right. Most of these wind generators would not be spinning in the summertime. So every one of those trucks that we see driving around have about 350 to 400 different parameters. Truck parameters, sensors, pressures, temperatures, speeds, fuel consumption, everything like that. And to be able to have that information in hand is vital, being able to diagnose what's going on in the truck.
Rajant Corporation is the manufacturer of the breadcrumb wireless mesh system and the developer of the InstaMesh protocol. Each breadcrumb node is an intelligent repeater, wireless access point, and a wireless to wired bridge. They are specifically designed for the harsh environments of mining and military, are available in different frequency bands, and can be battery or AC powered. The InstaMesh protocol is Rajant's key to unlimited network mobility and scalability. In a true ad hoc wireless mesh, the robustness of the entire network actually improves as the number of nodes increases. Only InstaMesh has demonstrated this in real-world deployments. One of IOC's communication goals was to implement a single, robust wireless network that could support all of its planned applications. These included dispatch, condition monitoring, drill management, VoIP, pump controls, video, and general Wi-Fi networking. In the fall of 2008, fresh off the highly successful installation of a 200-plus node mesh system at Rio Tinto's Kennecott Copper Mine in Salt Lake City, Rajant began installation of a mine-wide wireless network at IOC. IOC has two separate breadcrumb networks totaling over 100 mesh nodes and growing as new applications are added. The fleet network consists of shovels, drills, auxiliary equipment, and haul trucks. There's also a number of semi-stationary communications trailers that are used to ensure coverage in remote areas.
So we get that signal out there and it tells us whether the motors are running on the dewatering pumps. We're dewatering. We're pumping all that water up. We pump it up to the next basin, the next holding pond, and then over into the lake on the other side. If that pump goes down, and it happens many times, it freezes solid. All those lines, all the way up to the next basin up there, will freeze solid. We hook up to the instrumentation down there, i.e. monitoring the motor status. So, and of course, trying to get a radio signal out of there is pretty tough.
So we send all this data real time to the database, and after that they can see a trend. So they can see if the current is going up. They can diagnose based on all those indicators.
IOC's second network is dedicated to the autonomous train which hauls ore from the mine. Both IOC wireless networks have multiple wireless-to-wired land bridges, which are also used as high-speed mesh connections, a capability unique to Rajant's InstaMesh protocol. For more information, visit www.rajant.com.